Hey everybody, this is Alex Merced, and again, if you've been enjoying these videos on data topics, make sure to subscribe, like the video, and leave a comment. Also, make sure to follow me on Twitter and LinkedIn. Now, bottom line is that today what we're looking at here is a denormalized data set. So to understand what it means by denormalized, best thing to do is to see what it looks like when it is normalized. Okay, so let's just see here. Like if I want to normalize a data set, the reason being is just because I'm seeing a lot of repetition in the data and I might prefer the data sort of separated out. So in this case, what do I see here? I see the same movie mentioned several times. I see the same directors mentioned multiple times because we have different actors. So the idea is that there's essentially one record for each actor for each movie that they were in. So here we don't have any duplicates of actors because we don't have two actors in the same movie, but you get the idea. So what happens is like every permutation of this data gets its own row in a denormalized data set, which is great for when you're running analytics because then you don't have to combine different data sets together. Okay, so in that case, you save that step in the processing. But on operational side of thing, where you're dealing with like storage of data, this can get really expensive really quick. Okay, it can also be really hard to maintain and make sure that the data is accurate because, hey, if I want to update Alice Brown's name, I now have to update it on two records or two rows. And if I want to update John Doe, I got to update it in two rows. So this can get tricky to maintain on the operational side. So in that case, I may prefer when the data is kind of being created because people are doing transactions in sort of a data or like in a consumer application, then I may prefer it to be normalized. So how would I normalize this? Well, we would probably break this down to a movie table. Okay, so we'd have our movie table, and for that we'd probably still have movie title and movie ID. Okay, so in that case we would bring those over. Although we don't necessarily need two mystery islands, so I can pop that out. Delete row, and I don't need two space adventures. We can pop that out. Okay, and in this case, we're going to treat it like each movie only has one director, so we can have like a couple things that are just first. Let's add the stuff that is sort of unique to the movie. So let's add a genre field. Okay, that release here, that's kind of unique to the movie. A rating for the movie, that's kind of unique there. Country, running time. Okay, so there would be my movie table. Okay, I would just say, hey, here, sci-fi for this one, mystery for this one. Okay, and a comedy for this one. Okay, then the year. Okay, and the rating. You're starting to kind of get the idea. Okay, so as they see the stuff that is unique to that movie, we're going to keep in the movie table. Okay, USA. Actually, USA, the country we might want to still have in a separate table. So we'll denormalize that or normalize that. Control X and put the running time here. That is unique. So Control C, 120 minutes, 105 minutes, C, 90 minutes. Okay. So now on top of a movie table, well, we're going to want a director table. Okay. So actually just do this way. We'll have a director table where we would have the director's ID and we would have the director's name. And we would have 1, 2, 3 directors, which would be, let's do it this way. Control C. Okay. Okay, so there we have our directors. And then we're going to have our actors. Okay. Which again, we'll have ID and name. So you see, we're breaking this up into multiple tables or models. Okay, and then we'll have country. which will have ID and name. And we have USA, UK, Canada. 1, 2, 3. Okay. So there we go. We have country. So now what would happen is that now movie would have like country ID. So in that case, that would be like 1, 2, 3. Then it would have like a director ID. Okay, then we would see here director ID would probably be like 1, 2, 3. Now for actors, since actors can be in multiple movies and movies can have multiple actors, then we're probably going to want sort of a separate table to join them called like movie actor. Okay, which would have an ID, an actor ID, movie ID, and an actor ID. So if we take a look back at our original data set, okay, we see in Space Adventure we had Jane Smith and Mike Johnson. Jane Smith and Mike Johnson, that's 1 and 2. So 1 and 2, they were both in movie 1. And then in the second movie, Mystery Island, we had Chris White and Sarah Green. Okay, so they're going to be actor 2 and 4, or 3 and 4, who were in movie 2. And then we had actor 5, Emma Wilson, in the third movie. Okay, and this way we're able to capture all the movies. And again, now in this case, I'm not having to repeat the word Mystery Island. So now Mystery Island's only listed once. There really isn't any piece of information that is repeated more than once, making this overall more maintainable. But again, it's a lot of models. So again, if I'm on analytics, where I'm not necessarily really creating new data, I'm analyzing the data that already exists. What's going to happen is if I keep the data here denormalized into all these different tables, well, then I have to join them. Okay, and that's a lot of processing of having to like match all this data to its IDs and create a completely denormalized data set. But again, basic idea is denormalized is when you see everything sort of in one table. Okay, they're not separated out into separate tables, linked together by foreign keys. And a normalized data set, as you see here, is basically a data set that's broken up into many models that relate to each other on their foreign keys. Okay, so this way you have data that's more maintainable because the same data isn't repeated as much. So you're going to end up generally taking less storage space to save the amount of data, but the catch is there's more processing work when you need to join the data. But again, on the operational side, you're not necessarily always joining the data, only when you need to. A lot of times you don't need to. Like to add a movie, I don't necessarily need to join the data. Okay, to add a director, add an actor, add a country. But again, when I'm running analytics, that need to join becomes greater. That join can cost more, so then it becomes likely when you're doing your ETL work, so exporting from your operational systems and moving them into your into your analytical systems, you would possibly denormalize that as one of the transformations you do from one step to the next. So that's the deal there. So hopefully that gives you a little bit of flavor between a normalized data set and a denormalized data set, or other way around, a denormalized data set and a normalized data set. So again, when we break it up, that's normalized. When we bring it all back together, that's denormalization. I'll see you all in the next one. Again, like, subscribe. I'll see you all later.